The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone. I am geologist Philip Ong, here with Mr. Dane DuPont from HVO, the Hawaiian Volcano Education and Resilience Institute. We're here today with our ASL interpreters. Mahalo for joining us, you guys. Today is Thursday, October 12th, 2023, and this is the Hawaiian Volcano Tracker. We have an ongoing intrusion on Kilauea. Lots of earthquakes followed our update last week. They've died down a little bit, but still ongoing above background here, Dane. And lots of hubbub, probably as a result of some of the USGS reports and some of the imagery that's coming out here. How's your week been?
Oh, doing pretty good. Been watching it. Of course, all the earthquakes up there and some of the inflation as well. Stuff we'll be going into here in the broadcast. But yeah, it's been good.
Yeah, so awesome. We'll get into it. There's a lot to cover. We're going to refer to some of the previous activity in this area, as well as the overall big picture patterns that have changed from 2018 up until today. So we'll get into that here shortly. But I thought before we get into our full update here today, I did want to highlight that Dr. Jim Kawikawa was the first Native Hawaiian to lead HVO this past weekend on Sunday. Here's an article in Hawaii News Now. I won't dwell too long on it. I just wanted to share, here's a picture of the first time I went to see lava flows ever, and it was Dr. Jim K who actually took me out there. as a volunteer with USGS. Lots of research of his that he's done over the years. I think we maybe will come back to focus on that at some point in the future here. But just want to give a shout out, rest in peace, all the friends and family, all the HVO family, USGS family as well, Native Hawaiian family, likely touched by Jim's passing here. So to you, Jim. All right, so that said, we can get into our Hawaiian volcano summary here. So let me get the screen rearranged here for you guys. Let's have it say summary and flip our screen big for you guys here so you can see what's going on. So in this week's Hawaiian volcano summary, you see this map released by the USGS today showing an area of uplift detected by satellite that's southwest of the main caldera. This area is bound on its east and south by this swarm of mini earthquakes that have occurred over the past 8 days or so. And this activity is focused outside of the main caldera and seems to still be ongoing through the various monitoring signals. If we look at the earthquake rates over the last month on Kilauea, you see that this peaked just about 1 week ago, the day after our update last week, and quickly came down to lower levels, although these lower levels are still quite a bit above the background level here. The background level might be 30 earthquakes per day in this area. We're currently in a range of 150 earthquakes per day. And last week, over the weekend, we peaked over 300 earthquakes per day. So it's still above background, but reduced from its initial burst. It seems likely that this first burst of earthquakes may have actually opened some new pathway, wiggled some underground blocks to allow the magma to potentially move. What we're seeing on the sand hill tilt meter shown here is a whole lot of inflation to the east, the area where we showed on that map by the USGS, but not as much happening in the main caldera to the north, the Halemaumau. So this is a little bit different than we've seen in the past. And to go along with that, we have GPS signals from areas like the crater rim, where if we show you the north-south component here, it appears that during the beginning stages or just before the last eruption, there was a large offset and the ground moved substantially, not only here at crater rim, but also at Byron's Ledge. So there's certainly something that happened to do with the last eruption that changed the way that the ground is configured. When magma pressure came back in shortly after the eruption was over, it's now moving things around and creating some slight variations in the patterns we've seen. So we'll dig into that in our full update. The bottom line is that in this area south of the caldera, the ground is rising, moving quite quickly, exceeding rates that we've seen at any time in the recent past. And this indicates the magma is closer to the surface there than it has been in the recent past as well. However, it's very rare to have an eruption in this area. We'll review in our full update what it takes for that to happen, or what it took the last time for that to happen. But it does involve the Kauai fault zone and the adjustment of the whole south flank of Kilauea as a result of this refilling of the caldera area. So the USGS says an eruption could progress from nothing to earthquakes to lava in very short order. However, there is no sign of this occurring now, and historically it would be unexpected as well. So we'll wait to see if we continue to break the patterns here over the next days and weeks, or if we once again are seeing the initial stages of buildup to the next eruption within the caldera at Halemaumau. That's the story on Kilauea this week. Mauna Loa is still doing its normal thing. Deep earthquakes still ongoing at a slow rate. Otherwise, everything is as expected. That's the Hawaiian volcano summary for the week. So that is the summary. There's a lot of details to go through, of course. I think we can start, as usual, just to get out of the way, our volcanic hazard summary. We, as usual, are using the VOG Measurement and Prediction Project from the University of Hawaii at Manoa. They call this the VMAP project. And they put out this VOG forecast dashboard which, let me speed it up here and zoom it into our island. And you see here the areas that are projected to have some VOG impact around Kilauea Caldera Summit and southwest Pahala Nalehu Ocean View area, as usual. Not a lot of gas coming out right now. The measurement is 104 tons per day, and this input here. This can still be a nuisance or even hazard for people who are sensitive. So right now, it's actually among the cleanest air that we have in between eruptions of the volcano. And if you are one of those sensitive people, then this is the best time to prepare to make sure you have your house in order, that you have ways to close your windows or filter your air for when the next eruption does begin, if it comes sooner than later. We've seen these earthquake patterns lead eruptions pretty quickly, so we don't know if it'll be days or weeks or months, but for sure it's coming. And at some point, it'll happen quickly, and best to be ready for the gas before any of that. So that's really the hazard summary for the week. As usual, we like to step into the Purple Air Citizen Science Monitoring Network. So here's a Purple Air website, and showing green for all the stations island-wide clean air this week on Hawaii. Moving on to our monitoring, and there are a lot of updates put out by the USGS now that they are doing them daily. So I will try to just highlight the important bits here. There have been some changes and evolutions of the wording over the last week, so I'll try to step through it here a little bit. I wonder if I can maybe make this bigger. Yeah, that might work there. All right. So we'll start off at Friday last week, the day after our last update. This was a day that peaked the earthquake counts. So they note a lot of things in here. Not erupting. They do note the volcano was still inflating, but the inflation had slowed down compared to the previous days. They all week have been noting that inflation at the summit remains close to its highest level in over 5 years and has returned to the levels seen just before the last eruption on September 10th. So the seismicity they note began October 4th with increasing to 320 earthquakes within the 24 hours of Friday. So that was from Thursday to Friday there. For many of these days, they note the earthquakes occurring at depths of 2.5 to 3.5 kilometers, 1.5 to 2 miles below the surface. We'll see that this is actually not quite right, and they'll correct it later. But this is the initial thing put out. They do note that the trend of activity parallels, but slightly south of this December 1974 eruption events. So this December 74 eruption area is a good reference point for people, and we'll see that on the map here when we pull it up once again. Otherwise, many of these earthquake reports are noting which hours the seismicity comes on and off, but the pattern over the week was it starts, it slows down, it starts, it slows down, and we'll look at that in more detail coming up, but I won't read through all of it here for you. So coming to Saturday's report, highlighting some differences here. They say 170 earthquakes that next day, so down from the 320 just reported. They're noting the same depths, and also they're reporting 100 tons of SO2 per day reported on October 6th. All throughout, they're noting no unusual activity in either rift zone and the typical gas hazard analysis there. So Sunday, things are still pretty status quo with their updates here. They do note the slight changes in tilt, the changes in earthquakes, about 100 that next day. And we'll just move on from that one here. Come into Monday. They still note that activity continues. They say inflation was slight. Here we see something new. The tilt meter located just south of the summit is experiencing technical issues that HVO is working to resolve. So this is a Sand Hill station, what we'll look at here in a minute again. That shows that offset that maybe was curious when we put it up on the summary. Reporting earthquakes once again, 125, same references as before here. Really, it's on Tuesday when things take a turn where they change the opening sentence of their summit observations. The activity summary is the same, not erupting, nothing unusual, heightened unrest. So here they say, let's see, where are we? This is Tuesday, right? Okay. They do note episodic heightened unrest continues in the South Summit area of Kilauea, and an eruption in a region from Hale south to the December 1974 events could emerge with little notice 1 to 2 hours during peaks in its activity. So it's that statement that caused a little bit of reaction from the public here, because this was not something that was written in the previous days. Right? So could emerge with little notice 1 or 2 hours during peaks in its activity. That's the biggest change there. Everything else is rehashed. Inflation is still high. The tilt meter went off scale during the peak activity on October 6th, but has been reset and is showing continued inflation, but at a lower rate than before. They note GPS also shows uplift in the south, and earthquakes were still ongoing there. So that's what really changed the wording there. And they repeat that wording once again on Wednesday. Episodic unrest continues, could emerge with little notice. Everything else is pretty much the same there. And then coming to today's update, the most current one, they note something slightly more nuanced here. Episodic unrest continues in the South Summit area of Kilauea. No eruption is imminent, they now say. But an eruption in the region from Hale south to the December 1974 events could emerge with little notice, 1 or 2 hours. It's just a slight rewarding there. Inflation remains high, returned to the level just before the last eruption. And otherwise, things are pretty standard to what we saw before, except the earthquake numbers are quite a bit down still, 70 earthquakes in the summit region. So as you might remember, 320 that very first peak day, so it's still above background, not nearly as many as before. So those are all the text updates there. Not a lot of guidance exactly what's going to happen. It could erupt, it could not erupt. If it erupts, it could happen quickly. It could also not erupt for a long time. So it's really hard. They're trying to cover their bases there, it seems, with all that. So to dig into a little more, let's look at some of this data. Here's our monitoring data from the last week to start. Earthquake counts. There is that peak day, or actually the peak day would have been this one over here. But just to guide you on how these plots work, this is a week-long plot, earthquake counts per day. And usually the partial days at either end of the graph don't get fully counted. So this is only counting part of a day, this is only counting part of the day. So you really got to ignore those two ends. And it's really this part of the graph in the middle that counts. So this was the second day where earthquakes had come down a little bit. The third day they crashed quite a bit, and here they are pretty steady for the last week. Looking at that similar week of time, but now at depth, the depth profile of these earthquakes. The ones we're seeing are this orange band up top. That's what's been causing all the earthquake counts. There is still seismicity happening at the deeper levels, marked in blue, usually around a Pahala area. But you can see this is not what's really guiding the signal here. Interesting to note that within the last week, we had that first ramp of earthquakes, this first peak of couple days there, which you see is a heavier colored band here at the start of this graph, with a little gap right there, not lacking earthquakes, but fewer, and then it restarts right in here. Right? Corresponds to this plot we see right above as well. And then that goes on for a while, and once again, just within the last day here, appears to have another gap beginning. So interesting to note, as we talk to you guys now about what's happening, the volcano does seem to be changing its behavior with a little bit less earthquakes at present right now. So we'll see what happens next. For that same week period of time, here's the tilt at Uekuhuna. This is the station that's north of the Caldera, near the site of the former Jagger Museum. And you can see there that the tilt has been rising for all of the last week. Little variations. It seems like this one is not quite that typical deflation-inflation shape. So you have other things happening in there, which might be just magma finding different pathways and pressurizing one or the other in turn, and things moving in between, perhaps causing these little signals, right? So you have something like that possibly happening in here. Something like that could be happening maybe in here. This looks like it might be a bigger deflation inflation typical signal there. And if you guys have not been following us for too long, we've talked in the past about how these deflation inflation signals are thought to be caused by the movement of denser gas poor magma downwards and having the frothier stuff come up, but they have to go through the single narrow hallway, so one's going to move out of the way, and so the volcano deflates as the flat stuff drains away, and it's replaced by the fresh stuff, which then swells it again. And it's a natural just cycle of the volcano to move and rearrange its fluids underground through these narrow pathways. So that's all thought to be the background of Kilauea, and within that you see these other little trends. But really the important pattern here is this big slope increase from more or less, we'll call it -1.5 to +1.5 microradians there. So 3 microradians a change, it's not a huge amount, but it does show that Hale Mauna area is inflating a bit. Right? For the last week, we have on the screen the lava depth. This is not really relevant because the ground is not moving there, but the data was offline most of the week, and we see it has come back online. It does still show those variations across each individual day. Come back to that here when we look at the month-long plot. But sticking to 1 week, here is the map of earthquakes for the last week, counting all the small ones from the USGS. And note once again that we have this big cloud southwest of the modern Caldera. The Caldera itself is actually still visible here to the north. Some seismicity, but not too much. And where else there is not seismicity is here in this upper East Rift connector, or anywhere in the East Rift itself. Or really, if we think about it, the Southwest Rift, the volcanic Southwest Rift goes off in this direction. Not much happening there either, to be honest. And so it's really this, what we call the seismic Southwest Rift area to the south here, Southwest Rift connector, that is showing this activity, as has been typical over the last 1.5 years or so now, as we'll show you guys. You still have south flank earthquakes occurring, showing the south flank is still moving. We've talked a lot in the past about this little triangle of land between the southwest rift, the seismic one, the southeast rift connector, and the Kauai fault zone, that triangle right in there, and how that whole zone has to adjust out of the way from the summit, and that has to do with the south flank getting out of the way as well. So we'll show you guys a map of earthquakes from a longer period of time where you really can see that triangle more easily coming up here. And that's the map for the past week. So now to the last month. And it turns out that today is the 12th. The last eruption ended on the 10th of September. So we're now fully over 1 month away from the last eruption. And this entire graph is showing everything since the last eruption ended. So you see the very low rates of earthquakes per day as a background here, 20 to 30 usually. There is our jump. This was the day we did our update last week. And the earthquakes jumped up, came down, and now they're flat higher up, above background still. Here is a similar depth and time plot for the last month. So here is the period following the eruption where it was still recharging. And then here is where it starts pressurizing near the surface with earthquake swarms. Tilt for the last month over the summit. Similar story. You see more of these deflation inflation signals like this. You really see how small the one we just had. That one was really quite a small one right over there compared to some of the other ones we've seen over the past month here. And over the past month, you see -10 to +5, or almost +10 there, 15 to 20 microradians in total, really tilting up. This is a station at Sand Hill, SDH, that is really nearest the center of the action. And this station is showing 2 components. These numbers are compass directions. And so 226 and 316. The blue one is the one that points north towards Hale Mauna and north-northeast, and the green one is the one that points east towards this area of inflation more recently. So the blue line was following that summit pattern until right around the 5th or so, right in there. And you see the green line was actually rising faster and at that same time also changed its slope and seemed to slow down a little bit while still rising. And so moving through time, first there's that's around in a fifth. So we come back to our earthquakes, and that is when the activity begins, is right there at fifth. So it seems like once the earthquake swarm begins, we see the change in tilt, almost like something was released, like some blockage, or you see a focus away from the summit. The blue line starts to go down, and the green line continues going upwards. So that could be one sign of a shift from the main summit area under Halemakma'u, slightly further to the south, right? But this station has got some other issues. We see here it goes flat there and there. This is when the USGS noted that the station is experiencing technical issues. They note that it was then reset, and you see there's a data gap, some offset here. It's not quite clear how you connect this data to that. You probably can't so easily with what we see on screen here. So maybe consider this trend and consider this trend and ignore what's in between there on both of those. So it looks like the blue line is still going down since they restored it and reset it. That pattern seems to still hold, inflating to the east of Sand Hill, but deflating a little bit to the north. And so really that would be what would show you a shift. Following the tilt down the rift zone, we get to Pu'o'o, and we've seen this signal show up for the last few weeks here. We have been fairly sure this is not a volcanic signal, but as far as what exactly it is, that's not been clear. So we considered that the station location on Pu'o'o crater has been subject to collapses of the crater in the past and ground movement there. That was one possibility. But now that I look at this plot, and whatever's happening there seems to be progressing back towards what it used to be, it doesn't seem likely like the crater would have collapsed and then uncollapsed, or something else funny going on in there. And as we talked about in the past, there are plenty of times where there is noise that gets introduced to the data, whether it's some animal chewing on a wire, or something actually blocking the sensor, or some bad connection. You know, maybe one of the plugs got loose and there's water getting in there, and maybe the water was able to get in there when it was rainier, and maybe now it's been drier and it's drying out. I really have no idea, but there's something funny going on here that we can be pretty sure is not volcanic, because this signal does not show up anywhere else in the area on any other signal, not on GPS nearby, not in GPS slightly further away, and not even on a tilt nearby there as well. Here is the tilt of the next station down the rift zone at Jonica, showing deflation as normal, no action happening down in the Lower East Rift. So everything's still good. The pattern really has shifted to the summit, and if anything, to the summit more towards the west, as we see the earthquakes now, and we'll cover that here shortly. But continuing our monitoring signals, 1 month of lava depth. The important thing here is our data is back online at this very right end, and it's showing a similar trend of really not a whole lot of movement right at the surface where this laser is pointed, which is only one spot in that western basin of Halemakma'u lava lakes, hardened crust. So nothing funny going on there. SO2 is still low. We can move on from that, and here is the last month of earthquakes. So we'll get into the earthquakes here next in more detail. But before I get to that, I just wanted to remind you guys who maybe weren't with us last week, we do have a couple of other examples of tilt at the Sand Hill area. This plot is of the eruption that just occurred last month. That occurs at the very right end of the graph here. And I wanted to point out that in that case, we had inflation both in that area south of the Caldera and in the main Caldera as well before the eruption began. So that's kind of one pattern that we see. That was what happened last time. We're already not seeing that this time. Something's a little bit different. And so as another point of comparison, here is a period back in August of 2021. And interestingly, this is something that the USGS refers to in their map they just released. So in this case, you see there goes the area south of the Caldera, rising actually was a two-stage intrusion, part A, and part B here, and it stabilizes. And while you note that the first part of that intrusion did show also inflation at Halemaumau, the second part of that intrusion showed deflation at Halemaumau, while the area south of the caldera kept inflating. So in fact, not only did something happen, it happened right then, right in between these two pulses of inflation in 2021. So we'll come back to this date right here, the 26th of August, 2021, and right around then is when a major shift happened on the volcano that times is coincident in time with this intrusion. So we'll come back to that here when we look at that as well. But we need to talk about the earthquakes some more. So let's put the earthquakes on screen and start off with a wide map here, showing the pattern of earthquakes across the island. You see we have our background earthquakes around as usual. We have earthquakes under Mauna Loa. Some of these are fairly deep up here. This one I want to say 23 miles, 28 miles. This one might be shallow, some shallow adjustments. Likely Mauna Loa has a south flank that can adjust in relation to Kilauea's action over here as well. So not unexpected to have some slight activity, but really you can see the pattern is much different on Mauna Loa than on Kilauea. And this is a pattern that we really look for as a sign of activity. These clusters further to the south are deeper as well, near Pahala. This is all a feeder system to Kilauea. So it comes from deep and then moves laterally that way, we believe, at least one of the pathways, and then works its way towards the summit there. So really it's this pattern of earthquakes right around Kilauea summit that are there, not so many in the caldera, mostly to the south. And you see they're reaching down to the edge of, you see these lineations on the Google Earth imagery. These are actually cracks, fault scarps of that Kauai fault zone. And this is what the Southwest Rift Connector actually is the pathway that connects that summit area to the Kauai as a third leg of that triangle right there. And so you see it pretty clearly drawn there. So let me show you a few other ways to look at this. If you go to the main USGS page and you know which buttons to click in the right order, you can actually get cross sections. So I've just drawn here for this is the earthquakes for the last 4 weeks. But what I've done is I've filtered them out to only include the shallow ones and not the deep ones here. So I'll show you what that looks like. First of all, this is a count of number of earthquakes over time. So following the last eruption, earthquakes were happening very slowly. And then here they start on the 4th of October with very many happening in a short amount of time. The steeper this line, the faster they're happening, basically. So happening very fast, happening a little less fast, but still pretty fast. More fast, less fast. There's a little pause right in there. Then they pick up again, slow down, pick up, slow down, pick up. So it might be slowing down here, and that's the overall pattern. Overall, it's still much more vertical than it is horizontal, which is why we say this intrusion is still ongoing. And the rates haven't dropped enough. Looking at a plot of depth versus time, this is similar to what we showed you guys before, month and week long, but we've really blown up the scale here because that's what that website lets us do. If you are curious, 0.6 miles is 1 kilometer. So this is essentially sea level, 1 kilometer down, 1 kilometer above. This would be 3 kilometers or 2 miles, and this would be 3 miles or 5 kilometers right in there. So you see here, time on the bottom. Here is the 4th when earthquakes begin, and they actually begin from as deep as 3 miles. We'll kind of bucket those first few hours all together. From as deep as 3 miles to as shallow as in its first opening hours. Right, looking more closely at this, most of these events are actually not reaching above this depth right in here. There's only 2 events that are, and maybe we can look at those more closely and not be as concerned. At first, you might be concerned if you see that. We'll see that that's not actually as concerning as it looks. The real ceiling here is right around there. That looks like slightly below sea level. That's the top of this intrusion, apparently. Cracking rocks right around there. So you see it comes in and activates a whole range of depths mostly between this 2 miles down and maybe a half mile down or so. And that yellow batch is earthquakes that are more than 2 days old, and these orange ones are ones within the last 2 days here. So what you can see is that the range of seismicity of depth has not changed a whole lot. It's kind of quaking in the same places as it was before. And if anything, that very first salvo where the earthquakes were at their highest counts might have been the most dangerous, and that's where something could have happened and didn't. So where we were to see that kind of flurry again with a broader range of depth, especially coming shallower, then you might be more concerned that it might be coming to the surface imminently. But we're not seeing that, which is why we're hearing not imminent. Looking in cross-section, this map over here, let's pull it back up, has an A and a B over there. And if we pull that together, the A is on the left, the B is on the right. And here is that same range from 3 miles, 5 kilometers down, up to that almost to the surface. Looking now at the surface earthquakes, here they are. Those are the two shallowest ones. And you can see that they're all the way to the east, all the way to the eastern edge of this cloud. So it's not exactly like the magma is coming in to here and it's trying to erupt straight upwards and cracking the ground above it. It's more like it's bulging the ground in that area. And that ground has a crack in it that happens to be moving because of it. And if we look at that, it's not so easy to pick out, but if you look at, let's look at the orange circles here. The one furthest to the east, which is now we're looking at a cross section here, is right around there, right? That's the edge of that orange dot. And if I come back to my original plot here, blow it up more, there's my orange dot right there, and there's Caldera. There's the edge of the caldera right there. So right against the edge of the caldera is how far those earthquakes are coming. So what we're looking at, in fact, with these two earthquakes is the edge of the caldera. This is a caldera fault getting activated by all this stuff bulging over below it, right over there. So it does not look like something breaking to the surface to me. Certainly if this intrusion were to find that crack somehow, then it could use it, but it doesn't seem like it's quite lined up right now. It seems to be actually deeper to the west and coming shallower to the east. And it's not quite clear exactly where the magma pathway is. We know that earthquakes happen where rocks break, and magma itself, the actual, if you have a body that's large enough, it can't actually break its liquid, it just sloshes around. So you typically don't get earthquakes where you have a lot of magma. So it's not quite clear if there's a lot or if it's just a narrow trickle. But if there was a pathway, you might consider it possibly being through here where you have a little gap where it could be causing earthquakes to the side, or maybe it's actually more right in there if it's a skinnier thing and it's hitting both sides. So it really seems to be offset to the west from the main caldera where the magma is coming up, which is interesting if we note the cross-section that we showed last week as well. Here are those depths. Right, this is slightly different because it actually counts the surface is 0 and 1 kilometer down is what would normally count as 0 as sea level here. Right? This would normally be -1 and 0 and 1, 2, 3, 4, 5. Right, so we're looking at the depth between 5 and 3 kilometers all through here, like off to the side of the South Caldera, and up as shallow as somewhere in here or so. So maybe if you were to say, Lord, how does that fit into all of this mess in here? Maybe you have something coming from the South Caldera reservoir. It's just some little finger or something, or some pathway that actually allows it to go off like that. And then it can affect this area just off to the side of the caldera. Right? Note how the South Caldera reservoir is broader, wider than the shallower stuff. It actually exceeds the modern caldera's boundaries on the surface here. So that's where it's all happening. It's not clear at all what the configuration is, but here is the setting where we believe this is happening all through here. And to note, the seismic southwest rift, this is a zone that we're seeing active all through here. So when we see it trail out to the southwest, we're seeing that active. We're seeing this active over here, right? And so it seems like all through here is the zone where we're having this injection. And could it burst to the surface? It certainly could, but that's not usually what happens in this area. Normally the magma goes back through the middle up the top. And if it's going to go southwest rift, it'll then go back up this pathway this way, or more easily, it comes up and out like that. So we'll wait and see how that goes. To point out some of the historical patterns, we can go back quite a ways. This is 2004 through 2006. This is an image also showing difference in elevation from satellite, InStar technique. So there is that area of deformation, almost identical to what we're seeing today. Right? Similar area of uplift southwest of the Caldera. And when it happens, it seems to actually activate seismicity along that seismic southwest rift connector right over here on its eastern boundary. You see that happen there in 2006. I'll fast forward here to this map. Oh, that's the wrong one. To this map of 2021, where they show uplift, that same area, earthquakes along the right side of it right there. And the map they just released today, which shows center of uplift and earthquakes in that same area once again. So what we're seeing in that sense, this is not new. Maybe if anything, it might be the rates of uplift might be the difference there, but actually where it's happening and how it's happening are not that new. And so besides, go back to 2006, besides 2006, here's 2015, where also there was an intrusion in this area. So there it is, that same area activating with earthquakes. This is all pre-2018 eruption, pre-2018 collapse. The big difference there is you're seeing earthquakes here also on a southeast rift connector, right? That would lead to Pu'o'o, which was still erupting and active at this time. And so you see that in 2015, also 2006, right? There it is still. In 2020, we have an intrusion in that same area, closer to the edge of Caldera, right in there. This was a map that came out with the USGS Volcano Watch at the time. Not to dwell on all of that, but just to show you how common this is there. And we actually had this released by the USGS as well, which was a map showing that what that cluster looks like. And what the seismologist has done here is highlighted these two clusters of earthquakes as different populations. If you look at the depth profiles, they actually are hitting different depths and are different bodies there. This was projected to north-south cross-section, east-west one. But as you may have seen this before, and as I might just flash it on the screen here, we've also put this on a 3D map. So there is those two clusters. The actual map on the surface looks a little distorted because we've skewed it like this. But hopefully you can see more easily that there is two patterns of earthquakes. The blue ones are shallower and closer to the summit, and then the red ones are the ones that are deeper and further off to the east, right? So, right, this is between the 24th and the 28th of August. That's that same date that something changed, really. And it seemed like it started off in one area, then something switched to the second area, and that's when things actually changed there. So to illustrate this a little more easily, here are earthquakes, month-long earthquake captures from the USGS webpage for different periods of time. And I've tried to capture the period before each eruption since 2018. So this is the month of November to early December of 2020. December 2020 was a resumption of eruption at Mauna Loa summit. And just to show you guys, at that point in time, we have earthquakes around the main caldera. Also to the southwest, they were still active then, and also to the southeast rift connector. You see all of that. And look how much action on the south flank over there as well happening in 2020. This was when we saw the period of, up until this point, magma had been building up in the east rift, recharging post-2018. And after this eruption happened, everything switched direction and went back afterwards, right? And that was the beginning of the end for this east rift connector modern phase here. So that was 2020. This is 2021. September. Oh no, sorry, this is July to August, just before that intrusion. So there's an intrusion happening down here. And you still see that southeast rift connector active there. So 1 month later, September of 2021 when eruption actually is going to happen. Here's right in between that. That was the 28th, right in between there. We start to see a big decrease in the southeast rift connector and a big increase in the southwest rift connector right around that time, following that double blue and red double layer intrusion there. Then coming to that eruption lasted a while, so now we got to jump all the way to 2020, end of 2022, beginning of 2023, when the beginning of this year we had an eruption on January 5th. And prior to that, you see nothing in the southeast rift connector, a little bit in the southwest rift connector, but quite a lot at the summit as well. So the summit was really dominating that one. It was more summit and less southwest rift connector. So that's one difference from what you see right now, because right now you're seeing none of this, but only this area right through there. Right? It may build back up over the next few weeks to include the whole area, but we'll have to wait and see there. So that was January of this year. 2 more for this year. This is before June of this year. Once again, nothing happening on a southeast rift connector once again, and very healthy southwest rift connector action once again. Summit getting involved in later phases as well. And finally, just last month, just 1 month ago, here is a capture of what that pattern looked like. Nothing on a southeast rift connector, and once again, lots of action on the southwest rift connector. So we seem to have shifted the storage area of the volcano at the summit. The summit is clearly one big area, but where else can it go? Where's the extra haul? Well, it used to be up until mid-2022, this southeast rift connector, and now no longer. That area seems to be completely shut off, and it's really the southwest where this is happening now. So hopefully that's a little bit more illustrative of what I've been talking about, this larger shift in the volcano, and why we have really no short-term concern right now of what's happening, what we can see happening for people living in the southeast rift. Right, the southeast rift, of course, is a rift. It will erupt again someday for sure, guaranteed, 1,000% chance, but it doesn't seem like it's going to happen this week. So that is the pattern there. Because we've seen so much mention of the December 74 event, I thought I would pull that out as well. So this is a paper from the USGS that recounts all the events of 74. And we're looking at right now earthquakes in Kilauea Summit region related to and preceding eruption of December 31st, 74. So panel A is from September to October. Panel B is October to December. And panel C is the morning of the earthquake itself. Okay, so this is a buildup from 2 months prior to that breakout of December 74. And you can see, actually, this was interesting because prior to this occurring, there was an eruption at Mauna Loa, more or less in here. And there was some blockage that occurred. That eruption ended in mid-74. There were eruptions in a summit in August and September. And December is going to be the last one of the year there. Still, that southeast rift connector is still open at the time. You can see earthquakes happening there, happening under the summit, and happening a little bit in that southwest rift connector. This is 2 months beforehand. And now that month prior to it happening right there, so getting closer to the eruption here, you see a lot more action in the southeast rift connector, more in the summit as well. And not only do you see the southwest rift connector active here, you see it actually take the bend to the Kauai faults and continue all the way down to this western south flank area, all the way down to there. This is very different from what we're seeing right now. Right now, we're only seeing it happening up in here. We're not seeing any earthquakes at all down in this area. Maybe a couple in here, but there is nothing coming this far down. This makes it very different from what we saw in 74. That is one aspect of it. One thing that is mentioned in 74 is that Mauna Loa was inflating. It was due to erupt in 75. And Mauna Loa, when it erupts, pushes, or when it's inflating, pushes in this direction. So there may have been a change where the southwest rift zone, the volcanic one here, couldn't actually open because it's getting pinched by Mauna Loa. By the way, Mauna Loa is inflating today. So if anyone is hoping for a volcanic southwest rift eruption, it's probably not going to happen unless something changes there, because you have Mauna Loa trying to push this thing closed. So that kind of rules this area out. We're not seeing earthquakes anywhere there either. Right? Okay, the day of the eruption, earthquakes begin over here. The eruption site's going to be more or less in here, right in there. But earthquakes actually continue all the way down that seismic southwest rift. This 74 December 31st eruption was only 6 hours long. And that mainly relates to what you see with earthquakes happening here. However, after that eruption was over, 6 hours later, for 2 weeks following, there were many, many, many earthquakes. And here is where they were. Further down that southwest rift, all the way to the coastline, right in there. And so really showing an opening happening on the southwest rift, almost like whatever was happening at the summit managed to wedge open this area of the south flank. It moves out of the way. Before it had been kept closed by Mauna Loa, pushing over it. As it moves out of the way, then essentially can drain that intrusion from the summit down in that direction. This didn't happen out of the blue, right? The earthquakes in this area had been showing already for months prior to the eruption actually even happening, as you see here. Yeah, so very different from what we're seeing now. The similarities are, we know that East Rift Zone is blocked. At that point, it was there. Today, I believe it's somewhere right in here, something like that. We have Mauna Loa inflating, so we think that we can't erupt over here on a volcanic southwest rift, which basically leaves us a summit as our main option. And if for some reason you can't erupt at the summit, maybe that's when you have an eruption pop out here off the side, like happened in 74. Right? So one last thing on this intrusion before I scroll it back here. There is this nice plot that's showing, here, show you the map first. There is a map in cross-section. A is over there. A prime is at the right side here. And what they're showing you, there is an A prime. And we're going to look at time. So time starts at the top and progresses towards the bottom. So December 31st was the eruption. That happens here, closer to the A prime part of that line. And then as time goes on, moving downwards, the earthquakes migrate to the southwest, and then migrate across, and then basically that whole area lights up, with a little bit happening over here as well. But you see that real migration that occurs following the eruption over that following day. So New Year's Day, 75, was the beginning of that intrusion, really focusing to the southwest there. So really interesting stuff as far as what could happen if we were to have a big earthquake on the southwest flank, or even moderate sized earthquake. Maybe that opens this possibility. That's why it's worth talking about this stuff. But it really is different as far as what we're seeing, as far as how open that southwest rift and south flank seems to be down there. I'll scroll this back up because there's a couple other things I wanted to point out. This goes through lots of different eruptions. But here is one that I wanted to highlight. In 74, there were 3 different eruptions. One was in July, one September, one December. And each one had a different area of inflation. So the first one was July. The center of inflation for July was here at this star. July fissures break out there and there. So pretty close to the center of inflation. Next was September. September inflation center is right here. Those fissures break out there. So July was there, but also here, there are 2 different subparallel fissures. Finally, the center of inflation further to the south was in the end of 74, with those fissures breaking open in December down here. And this is where you see the USGS leaning. If you see inflation center is shifting to the south, it does make this a possibility, even though this is one of the only examples we have of an eruption in this area right there. You can generalize more, but the point of this is the inflation centers can shift, and this is something we may see happening here too. You can see that in different GPS versions, tilt versions of the arrows here as well, but I want to move it on. So let me come back to this. So here you see the configuration of these 74 vents. Right? And they also highlight the mid-Mauna Loa eruptions in 73 vents of May 5th over here, and how these really align with this trend of the Kauai fault system right through here, right? That's the trend of these of these cracks. This crack seems to be opening along that Kauai trend, not the southwest rift zone trend, which is at an angle to it. And it seems to be, these may be a different angle than that. And so you're thinking this is really something happening within this triangle. Even at the time, they noted that this triangle might be an area of increased intrusions and eruptions over the coming decades, because they saw this pattern of eruptions beginning to occur in that area. So that is that layout of where those vents are. And maybe I'll come to, so you come to the very top so you can see the title of this. This is Magma Migration and Resupply during the 1974 Summit Eruptions of Kilauea Volcano, Hawaii. Fresh on paper 1613 from the USGS here. Okay, so that's a little bit more about 74. This is a map that I've shown before, and what this is earthquakes from 1970 to 2007, larger than 2.0, at different depths. So 0 to 5 kilometers, 5 to 15, 15 to 20, 20 to 60. They stack kind of like you see in this inset right in here. We're going to focus on the shallowest slice of this, which is up here, 0 to 5 kilometers, earthquakes. This is the easiest place to see this triangle. There it is, right there. It's shown in these earthquakes from the seismic southwest rift zone, that leg right there. Southeast rift connector, that leg right there. Summit is at that apex. And at the very bottom, this is the Kauai fault zone earthquakes that occur as well. So there you see them quite clearly, what's been active within the last 50, 60 years here on Kilauea. That's the wedge we keep talking about. So if we come to the GPS stations to dig into this a little bit more, let's pull it back to monitoring now. We can see these are the 2-year GPS stations plots. So compared to before, these are taking up more time. The time we're looking at is compressed into maybe half the graph or a little bit shorter of the graph here to the right. And these are 3-component graphs where the top component is east, middle one is north, and the bottom one is up. So if the graph is rising, it's going up. If the graph is rising, it's going north. If the graph is rising, it's going east. This one is going west. Right? So you can see Uikahuna is moving west and north and up. And importantly, when we zoom into these plots and we look at the rate of it going up, it's been coming up at a pretty high rate, right? Even higher than we saw prior to the last eruption and the one before that. And that's Uikahuna. We come east to Byron's Ledge. Byron's Ledge is moving to the east, to the north, and up as well. The rate is not really that different at Byron's Ledge there, but there's something unique happening over here in this north-south component right there, the big gap. And it's hard to line it up exactly, right? But you can see up here what happens is during eruption, you see this dropping down of the distance on the GPS, and then when eruption's over, it resumes its previous trend right there. All right, so it looks like to me like this right here is a drop of that eruption and coming up, but what's not explained is the jump from here to here. And if you remember, there were some big earthquakes and intrusions happening the days prior to September, and it seems likely that this is one that occurred. This Byron's Ledge block got pushed to the north and stayed offset, stayed pushed that way. And that's a difference that if you look hasn't happened any time in the last 2 years here on this plot. We come down to the Crater Rim station in the southeast. And similarly, it's moving to the east and to the south and up. Its up rate is getting very, very steep here compared to before. So you can see why there might be some alarm there. And you might say, okay, well, it's really getting close to the surface and cracking. If it comes up right there, it could pop for sure, but much more subtle in here. And this is something that is worth pointing out, is that Crater Rim has been moving south and then pausing a little bit during each eruption, moving south and pausing, moving south and pausing, moving south and pausing. It gets offset. It's moving south, but within the last 2 weeks has begun moving to the north. That is different, right? We've seen a little bit before, shorter term, following eruptions as well, right? Some adjustment happening there. But if Crater Rim is moving to the north and Byron's Ledge is moving to the north, Oh, let's see that. Did I mess this up? Let's go back. If they're both moving to the north, and something is happening south of there, and south of Crater Rim in particular, to cause this offset and this to occur here. Let's see if I can back this up. I might have to go back like that. All right. Okay. The other station on the summit to the southwest at the outlet. This is actually closest to the area of uplift that the USGS points out. That is moving to the east, to the south, and up. The up is actually very fast as well. This is why there is another one of these trends that can be a little alarming, how fast this is rising here. Right, to give you an idea, from here to here, let's see, what is that? Right, we're looking at maybe 10 centimeters in the last 2 weeks, right? 4 inches or something like that. 3-4 inches of ground is lifted in the last few weeks, just in one area, following the eruption last month. So that's really interesting. And if you look at the east component, it's actually getting pushed to the east much faster as well there. Right? And so that makes sense if the area of uplift the USGS mapped out being to the west of there as well. So that's a little different as well. And you don't see that happening within the last 2 years here either. Looking at the south flank GPS stations, we won't go too far, but I have these lined up in proximity to the summit. So the south flank stations closest to the summit are also showing very high uplift. This is the Ahua station, rising quite fast right there, getting pushed to the east quite fast. The Puhimau area also rising quite fast and getting pushed to the east quite fast. And furthest over, Devil's Throat. That one is not really that convincing. If I look at the scale here on the left side, these have an extra decimal point. So we're looking at 0.01. And over here, we're looking at 0.02, 0.05. Yeah, so it's a little twice the scale and 5 times the scale here. So these changes are much smaller, not convincing that it's really rising that much within the spread of data, but it is following its old patterns there as well. It is also getting pushed to the east and to the south as well there. Kind of zooming out, all the other stations in the south flank are not showing up. They're all showing these similar patterns there, right? So as we discussed before, it's that area within that triangle and really not Devil's Throat. If I come back to, let's find where was that plot right there? Yeah, so we're looking at the area right within here. Devil's Throat is more in here, and that area is not getting it. It's really more to the west, the western part of that triangle in there. That's getting the effect. Just to be thorough, here is the East Rift Zone showing down, moving to the south, down, to pool, down. Everything is pretty boring, just deflating across the Rift Zone there. So that's the last 2 years. To put it in a little bit more context, we're going to open up the 10-year plots. So now we actually have the 2018 eruption on here as well. And there you can see, for example, Uikahuna was going up, swelling prior to 2018, collapsed, and since then has been refilling, spreading, rising, and spreading at a faster rate than before there. Right, the distance we're used to seeing as a measurement between Uikahuna and Crater Rim back over here, and similar pattern at both of them there. Okay, so just want to point out for the last 10 years, you don't see an offset at Byron's Ledge on the north or at Crater Rim either, right? Over the last 10 years, this is really something that's just happened unique to this month, this past month here. Okay, not to dwell on that too long there, but what I can show you is the Rift Zone, what's happened to the Rift Zone. All the stations in the Rift Zone have a similar pattern where here is the collapse from the summit. There's a rebound period that they go through where they're getting recharged, and then it turns over and has been sagging since, right? So this is Kananui Ohamo on the Rift Zone, Kamomoa on the Rift Zone, same pattern. Pu'o'o on the Rift Zone, same pattern. Jacuzzi near Pu'o'o, same pattern. Jonica, same pattern. right? So it's pretty easy to pick those out as all being that same population there. And the south flank has had interesting things happening too. So here's Puhimau, that station that we're seeing still showing uplift. It's been showing uplift even before 2018. It was uplifting in that area. That area is part of that summit reservoir piston. So in the build up to 2018, it was rising. It's continued rising since then, right? At Ahua, prior to 2018, it was rising. It's continued rising since then, right? And in fact, one of those intrusions we pointed out is actually visible as a little offset right here during that 2015-16 era there. There are some other offsets here from that big 6.9 earthquake in 2018 that was on May 4th. So there's a little bit of that you see on the east and north components of these plots. But all the up plots you're seeing are actually showing that pattern of they were rising beforehand. Over at Devil's Throat, not quite as much, a little bit flatter, not really rising as much either. So that's more or less a borderline of that piston to the south. So we've seen them rising recently. We've seen them rising in the past, even before 2018. That's all normal for that area to be rising. It's more about how much is it rising and how fast is it rising. That's the real difference right now. Yeah, and otherwise there is that same pattern for the near rift zone stations there, right? But one thing that's quite different in some of these areas, looking at the north-south, here is a south flank at Puhimau. You see there's an offset, but it's basically going down, going south, going south, going south, going. This was in the no data. When you get to Makapui, Kalapana Trail, you see that in mid-2021, right in there, these things were going south, turn around and start going north. So Makai Makapui starts going north in 2022. The Kalapana Trail that was going south pretty fast, and then even faster, turn around and starts going north into 2021. And that's really the clue to why the East Rift Zone is blocked there, is because you have these funny movements of land in the south flank there moving to close a rift zone. This moving north closes a rift zone. This moving north closes a rift zone. And that explains that interaction. And these are the stations that are closest to the Kauai fault zone of that triangle, that edge of that triangle, that corner of the triangle there. So that's all the big picture stuff. There's one other thing I wanted to, I can kind of pull it out one other layer. This is going back to the whole history of GPS at Wikahuna back to the year pre-2000, right? So prior to 2000, Kilauea was still deflating in the long pattern of pool erupting. The summit was deflating. The first sign of that turning around was this anomaly right here that occurred in 2004 to 5. An extra injection of that first blob of extra magma came up. That was the first sign I think to come, because right here in 2010, 2008, 2010, things turn around. The summit then starts to rise. This is the whole build-up to 2018. Those are 10 years of the volcano filling. This scale here is 100 millimeters there. So yeah, looking at quite a lot of rise there, right? So it was rising really fast. Collapse occurs, and what I really wanted to point out here is look at this. Look at the slope of this. This is rising faster following that collapse than it was during the buildup beforehand, and that rate has not changed much at all. So here, if you look at it this way, the volcano is still repairing itself following 2018 collapse. We haven't got to some point where we've refilled and stabilized yet. We're seeing this extra high filling rate, and it's leading to more frequent eruptions. This could be part of that natural rebound of Kilauea, or it could be more magma coming from below through the whole system coming upwards that we saw beginning with the first blob happening here and then coming in here and continuing. The collapse occurs, but the magma doesn't stop coming in. It's just now working through rubble, and it's able to push up perhaps a little faster through there. One way of looking at things. Right, that's the Uikahuna station for the last 25 years. And one last thing to note here, this is before I had this USGS map released, but I was trying to figure out exactly what was happening. We can pull the outlet station as well. And this only goes back to 2008, so it shows a similar kind of pattern, rising, collapse, rising. But what I wanted to show is these stations do also have raw data coming in. They have rapid GPS they're plotting on here as these pink dots. So these ones are not as trustworthy as a blue, but they are raw data coming in here. And what you can see is that this looks like a real rising in that area southwest of the summit that you're not seeing elsewhere. We saw this once again, 2015 intrusion right through there, right? You saw it as well end of 2021, 2022, each of these eruptions, but it looks like it's more rising in that area. And before I had that map from the USGS released just today, then this was the best clue we had that was what was going on out there. So it really is all fitting within a pattern pretty well. Of course, as we've warned before, there are outliers. There's noise in GPS data, so we'll have to wait to really assess that long term coming up. So that was a real deep dive through all that data and the context and the history of it. We'll lighten it up here and finish it up since we're been talking so long, and we'll do that by showing you guys what the geologists have been doing in Kilauea. So visuals, Kilauea observations, nothing much volcanic, but the scientists are out there working. So their GPS campaign continues. They note that they occupy most stations in Kilauea at Mauna Loa every year since the 1990s, whereas less active volcanoes of Hualai and Haleakala are surveyed every 3 to 5 years. Only a couple of pictures here. Here's one of them out in the southwest rift, GPS station deployed over a benchmark, collecting data. See a cinder cone there in the background. That's one. Here's another one down by the ocean, part of their yearly survey. So not only do they have the instruments that are in the ground, they're transmitting to the internet all the time that we're looking at for the last several minutes here, but they also have these extra ones that can go out and deploy to collect data in places where they don't put them up all the time, where they can then have a bigger picture, less frequently, only every year, but you still get the full picture of it, and you can then tie it all together better that way. So that's still ongoing here. That is the USGS imagery from this week, although I thought I'd throw in a bonus little funny thing here, which is that the S2 camera that was deployed at the summit, so you got taken back to the USGS warehouse, and you actually have a cameo of the USGS warehouse from the inside of the S2 camera popped up here earlier today for a few minutes before they switched it off again. So yeah, just a little curiosity going on there. Okay, so that's Kilauea. Mauna Loa won't take us very long, but let's talk about Mauna Loa. Here is a topo for the last week, up and down as usual, nothing to see there. Pretty flat on average, really, right? Zooming out to the last month, you see that flatness here, right through there, but you see the overall longer trend of inflation. We have seen Mauna Loa respond to Kilauea's eruptions and somewhat inflation, so this little wiggle is happening through here. It may just be that, and it's hard to read much more into it than that. What we do know is that earthquakes have been happening deep under Mauna Loa. This is the last month of time and depth. The deep ones are these purple and blue ones, down at 40 kilometers, 30 miles or so. See that they were happening more so at the start of the month or a month ago. There was a big gap, and now they seem to be resuming. We have a few larger events popping off here within the last week. So that is still happening. As far as counts, they're still very low. Earthquakes per day maxing out at 10. So it's just not eruptive patterns. This is just adjustment reinflation patterns. For comparison, here's a last year eruption was not quite a year ago, so we still have it showing up here on that earthquake ramp up to the eruption. For the last 5 years, here's that same ramp up, but with a lot more broader buildup over the previous 5 years, including some seismic crises that really peaked several years into it there. So these are where the earthquakes are occurring, the purple and blue ones under Mauna Loa summit, right through there, really far down. And in cross-section up there. And finally, the GPS on Mauna Loa. So we see Mauna Loa, the distance north and south across the Caldera, horizontal, is slowing its spread, but still spreading, slowing from before. That's part of the expected pattern, right? It goes faster at the start. That's a similar rebound as I'm talking about for Kilauea and post-2018 collapse, right? This thing is rising up. At some point, you expect it to get flatter and flatter and flatter and even out. Very similar pattern on the upward component station right here, like that. And if we zoom it out to the last 5 years, you see that pattern compressed there on horizontal and there on an upwards component with that longer rise occurring before it right there. So first thing on this is that, as we have said before, and just to refresh, that's the expected pattern. Here's post 75, same pattern. That lasted, it looks like, a good 3 years of inflation at least before flattening out and then inflating more for another 5 years after that. You look at 84 eruption, that inflated for about 10 years following that eruption at different various rates here. So all that is normal to expect to see that GPS trend. That's really the earthquakes you're looking for out there. One final thing that I thought I would do here with Mauna Loa, because we have been talking a little bit about how Kilauea may affect it. The insight that was offered by the USGS that between two southwest rift eruptions, one in 71 and one in 74. In 71, you actually could erupt in a southwest rift, volcanic southwest rift, because Mauna Loa was not inflating. In 74, you could not, right? So they're actually being affected. And not being able to erupt in a southwest rift in 74 is what led to erupting out of the south seismic Caldera area, right? So what's going on with that? So I thought it might be fun to just put up 5 years of Mauna Loa and 5 years of Kilauea side by side. And you can see some patterns there. One thing that's maybe the most obvious to tell is the most recent thing here. As Mauna Loa is leveling off, Kilauea seems to be ramping up that same exact period of time. That's really interesting. I wanted to see this a little better. So what I did here was I superimposed them. So what you're seeing now is Mauna Loa is the red, Kilauea is the blue. The scale is a little different. Kilauea is moving on a scale of about 1.5 meters over this 5 years, whereas Mauna Loa is moving on a scale of about 0.5 meter over those 5 years or so. Right, so there may be more easily to see that contrast between a red and a blue. The red slowing down and blue speeding up right there during this particular era. You see that both volcanoes are actually spreading with time. So something is feeding both of them. It's not picking one or the other. They're actually both getting fed. There's enough magma to feed both. And it's just taking turns which one is expressing the surface deformation at which time. So you see early on, 5 years ago, following 2018 collapse, Kilauea is actually recovering pretty fast, magma coming into it there. Mauna Loa is also spreading, but at a slower rate there. This is that first 2020 eruption of Kilauea in December, where Kilauea relaxes. And note that Mauna Loa actually has a little blip that follows Kilauea's first eruption there, almost like it's a little response there. And it slows back down again as Kilauea picks back up again. There's Kilauea's second eruption in September 2021. It keeps going on. Mauna Loa is what comes next right here. It actually stops that 2021 eruption. And then once Mauna Loa stops, Kilauea starts again in January, then again in June, and again in September. And here we are at the very right end, looking for the next blip to come across the screen here. So just a little interesting contrast there in comparison. And really the most striking thing to me is this right here, right? What's happening after Mauna Loa erupts and she's recovering, Kilauea is taking advantage. And magma's coming in and pushing where it maybe couldn't push as easily before. And that's maybe how it all fits together there. So that is Mauna Loa update for the week. A few final things. Volcano Watch this week is focused on the Great Hawaii Shakeout. And they also add in earthquake energy budget, which is something that's new for Volcano Watches in my experience here. So the Great Hawaii Shakeout is a yearly event that happens in October. They say it's the third. Let me see what it says here. It's the. What doesn't it say? It's in here somewhere. I forget which part of the article it's in. Here we go. Well, so it's this Thursday, the 19th, at 10:19 a.m. And the idea is to drop, cover, and hold on. You want to drop because the ground is shaking. You don't want to fall over. You want to get covered in case things fall on your head. You want to hold on to your cover so the cover doesn't get shaken off top of your head and something still falls on your head. Basically, that's what it comes down to there. So the idea is that 10:19 on Thursday, the morning before our update next week, you can participate in the Great Hawaii Shakeout here. They also talk about earthquake energy budget, which is pretty cool. This is something that's people have asked about in tangential ways in the past. So I'll highlight a little bit of that here. So, okay. Shaking is just one way that an earthquake releases energy. Earthquake energy is also released in heat and mechanically. All those categories together comprise the earthquake energy budget, or the total energy released by an earthquake. So during an earthquake, rocks break and then slide past each other to release the built-up stresses. When they slide against each other, the friction generates heat. That's one of the forms of energy that's released. In fact, that's not mentioned in this article, but my old advisor, University of Michigan, would actually study earthquake products that created enough friction to melt the rock and actually have little ribbons of, it's almost like a magma that forms within fault zones there. I'm trying to not use the technical terms for you guys, but that's how hot it can get in faults. When a big earthquake sets off, it can actually melt the rock in localized areas within it. So certainly a lot of heat's being released there. Another byproduct of sliding is the broken bits of rocks that get slid along the surface there, similar to sawdust generated by sandpaper on wood, or rubber that comes off of an eraser on paper. So that's part of the energy, is to break the rocks into little pieces and grind them up. And the last one that they mention here is the radiated energy. That's what makes the ground actually move. Very rarely people actually mention seeing lights, hearing sounds. That's also part of the radiated energy they don't mention here, but that's also a minor part. Most of it's the energy you actually feel, the rocking. That's most of the stuff. Most of the energy is going to shake across the entire world as far as the energy can take to dissipate, right? With big earthquakes actually shaking all the way around the world and going in cycles all the way around the globe over several weeks. So that's energy budget, a little bit broken down for you guys here from the USGS Volcano Watch this week. And ultimately, this means that earthquakes of the same magnitude, meaning they have the same total energy, may spend energy in different ways. One earthquake may spend most of its energy mechanically pulverizing little bits of the fault. Another earthquake, maybe on a more developed fault, might spend more energy on the thermal heating or shaking the ground. That's why ground motion is not always comparable across earthquakes with similar magnitudes, even from similar locations. An earthquake that uses the bulk of its energy into radiated energy might cause more shaking than the same magnitude earthquake that spends all of its energy heating or breaking the surrounding rocks. So hopefully that's a little bit extra insight for you guys about why earthquakes feel differently, why people feel them differently in different places. All of that is just more complexity into that whole experience we have with earthquakes as humans. So that is a Volcano Watch this week. I do have a couple of final announcements to make here on our Community Watch, Community Corner. One is that in a national park, there are some areas still closed due to elevated seismic activity and inflation. The park has been more proactive now, and they're closing further areas. There's a lot of text on here, but they very wisely have included some maps. So here is the area of a summit of Kilauea. Yellow is the main Critterim Drive. That's still all open. Red is the area they've closed. So they have closed the Pu'upuai Overlook, Devastation Trail, and Devastation Trail parking lot, this whole area here. They've closed the old Critterim Drive Trail to Kanakakoi, the old viewing area to Kanakakoi. That's all closed, as well as a Critterim Trail to the other side of Kanakakoi, also closed. So all this area here is experiencing closures. At least these roads and parking lots are closed. It looks like some of these trails might still be open in some of these areas and maybe backcountry, but clearly there's no they're not wanting people to be in these areas in case something happens. Right. This is one area. This is a summit area, but because they are also considering the possibility of a southwest rift outbreak, there are more closures than just that in effect. We were just looking at the summit, this zone right in here. They have also closed the entire Hilina-Pali Road. That's this road over here. It goes all the way down to the overlook. That's all closed. They've closed the desert trail all the way around the Pepeyao cabin around the overlook as well. That's all closed. They've closed the Mauna Iki trail that goes to the Kulanao Kuaiki campground as well. Campground also closed. So really, this whole southwest part of the volcano is now being excluded from visitation in anticipation of a possible eruption there. So keep that in mind. Historically, the best place to see these eruptions in this area has actually been up here, the north side of the crater, because you're so high up, you can look down across the desert and see these features. People described in 71 and 74 watching the fissures migrate down the rift zone from there. We can see them moving over time. So that will be the area to, if something happens, to go, to go look if it's happening in the southwest of the Caldera area here. So that's the closures of the national park. One last thing from the park is that this following Tuesday is After Dark in the park, and that is the Hawaiian Chant event that we've been highlighting for some time now. 7 p.m. So check that out. That's one worth going to if you are able to. We will try to work with Two Pineapples and the national park to see if we can stream that for you guys. If it's super, super full, it might be challenging. We'll see what we can do there. And that is the community for the week. And Dane, I have talked myself out here after an hour now.
All right. Yeah. Thanks everybody for sticking with us. We rely on viewers like you to help us, get this channel out there. Every like, subscription, all that kind of stuff definitely does help in the grand scheme of things with the algorithm and all that kind of stuff. We also take donations on hvery.org/donate. And those are tax deductible donations. We are a 501c3 nonprofit, and appreciate all the support that we can get, because we do rely on that kind of stuff. So appreciate that. I know we've been running pretty over. I did see that you were talking about the earthquakes and stuff like that, and I was like, it's been a little while since we had that last 5.0 earthquake and connected to Mauna Loa, so I had to pull that up, and that was a year from today, but in 2 days. So it was actually a year from Saturday that earthquake hit. So we're pretty close to a year out from that one. That doesn't mean anything, but just that little. It's been a little while since we had a little shake, of that kind of caliber. So yeah, we do have just a couple questions here. Not going to spend a ton of time on these, but Richard asked, what are the sandhill tiltmeter anomalies due to it sitting on the slope of that uplift shown on the INSAR image?
That's a good question. I don't exactly have the answer there. I can only just read into what the USGS wrote. They wrote that it was experiencing difficulties. Then they wrote, let's see if I can find the text that they wrote here. They wrote that it had what was the terminology they used there? Not that I had maxed out, but let's see here. Maybe it's the next day. Went off scale is what they say. Yeah.
Mm-hmm.
So yeah, I'm not sure exactly what that means there, right? But what's different about what I saw of that signal of the sandhill tilt was that there was an earlier version of this plot, right? And when that earlier version of that plot, this line actually attached to down here. And this looked like it was still going up like that. So it looked like the station had been transmitting data the entire time. It was something about measuring the data that went wrong through here, right? And I really can't tell you what exactly happened there, right? I mean, we know these things have bubbles in them to help level. I mean, I wonder if there's like a limit. If things like tilting it's been sitting there for a long time, right? Ever since post 2018, they had to go and fix the station because it really had damage in 2018. But since then, imagine it starts tilting and tilting and tilting and tilting. At some point, it's going to tilt too much, and it's like, well, I can't measure it anymore. It might be as simple as that. Haven't seen that happen anywhere else, but that's one possibility. Maybe the USGS will tell us more about that, right? But I think we think that they actually then came and put in this offset for the data just to really emphasize how this is not the same baseline and the same stream as before. Like, this is not real data here, in fact, right? There's like something that happened in between. So it's a great question, Richard. I think it's more so something with the electronics of the instrument. And yeah, the fact that it's so close to that uplift area here that we show does mean it's going to tilt a lot, right? It didn't just tilt this year, it tilted in 2022 and in 2021 and in 2020, and all those times it's been tilting. So good question.
All right, this one from KW asks, what are the chances of an eruption inducing landslide causing a tsunami, or just in general generating a tsunami?
Yeah, so eruptions can cause landslides. Most often they're in a caldera. So it's not likely to cause one into the ocean right there, right? Now that can happen, right? If you're talking about maybe Mauna Loa or other volcanoes, that could happen, but then we're not talking about being very, very likely either, right? So there can be, I mean, I think more likely it's like something like 1975, right? November 75, we had a big earthquake. At the time it was reported as 7.2, was then revised to 7.5. Nowadays, most people I talk to consider it a 7.7 as far as how much energy it actually released. That earthquake in November of 75 caused an eruption in Halemaumau Summit that lasted a day. It also caused a tsunami that swept into Halape and affected and had two fatalities in that area because of it. So that's more likely. One big earthquake sets both of the things off. So to the point of, you can have an earthquake and an eruption and a tsunami happening all at the same time. Absolutely. But maybe not quite in order like that. If you did have, let's say you had an intrusion way down a southwest rift like we saw in January 75, right? And you did cause collapse of the sea cliff into the ocean, for example. Well, tsunami are really proportional to the amount of volume that's displaced underwater. So any chunk of mountain that falls in is a big chunk of mountain, but it's usually a lot less volume than a fault line underwater, because a fault line, they run for hundreds of miles. And one earthquake might activate 5 or 10 mile length of a fault. If you have 5 or 10 miles of a thing moving only, let's say, 6 inches upwards, and that fault is down at, let's say, like, I don't know, a mile below the surface of the ocean, or a half mile, you have some huge column of water that gets lifted up across a huge area that's displaced. And that's what really makes a tsunami, is more of those. So when you're talking about having tsunamis that are Pacific-wide tsunamis, those are almost always big earthquakes that happen along the Pacific Rim. You can have a landslide generate local tsunami, but those tsunami will be localized to near where the landslide happens. So if one happens on, let's say, by Halape, then you'd expect it to affect all the south part of Kilauea, maybe around Kona and Kohala, but it maybe not going to affect as much Kauai and Oahu, right? They might have some effect, but not as much as they might have from an earthquake from Alaska or Chile or Japan, in fact, because it's less volume and the energy disperses more quickly across a larger ocean basin, if that makes sense. So I'm really not an expert in tsunami, but that's the insight I can offer, having talked to people at the Tsunami Museum and other scientists, and happy to be corrected if someone has got other points of discussion here as well.
All right, let's do one more from Bill. He asked, if lava erupts in that area southwest of the Caldera, how quickly would it get to the ocean? Be a while.
It all depends how much. It all depends how much lava and how fast it's coming out, and it doesn't come out there very often. The area has a lot of cracks. So what happened in 74 was the eruption only lasted 6 hours. It was very gas rich. So it actually like covered a lot of area and moved fast, but it kept finding cracks and filling in cracks and filling in cracks and filling in cracks. So in total, I think their estimate of the dense rock equivalent, so you take away the bubbles and the gas of the rock and how much lava is left, what was left on the surface was only 3 million cubic meters. 3 million is very little compared to what we see in any eruption. You know, like our small one we had in June was 15 million cubic meters. So like 1/5, that's very, very small. And because lava was so runny, did it actually get all the way down here in 74 because of how gassy it was. But it was very, very thin. They say it was less than a meter thick almost across the entire flow, and really shelly and gas rich too, right? So it could happen if you have, you know, point one, right, how much is coming out and how fast. Point two, how close to the ocean is the vent, right? So if we're talking about from this area right up here, then yeah, it's going to take a long ways. But if it manages to propagate down the southwest rift and erupt further down, then it's a lot more likely, right? It's like the 1823 eruption that's off a map over here would have been one of those, right? So yeah, that's maybe the best answer there. Take a long time.
Yeah. Well, we've been going for a long time. I think we got about an hour and 40 minutes into this thing. You know, some good research in there and some information. And again, if nothing else changes, we will be live again on the Thursday, every Thursday at 5 p.m. Hawaii Standard Time. If something happens, we get an eruption, something like that, we will go live again and cover that. And we can also expect something like, if we do get an eruption, we can expect our partners, Two Pineapples, to be setting up to try and get the live stream of what's happening for you guys. They'll do their best depending on the location and all the specifics of what ends up happening. But all else, you know, we'll be back next Thursday again.
Yes, thanks again for valiant efforts of our ASL interpreters. The longer I talk, the more they have to sign. So apologies, you guys, but thank you for sticking with us here. I'm sure the community appreciates being able to understand information through ASL. And yes, as Dane said, we'll be back again next week, and we'll all be keeping an eye on what happens in Kilauea. I don't see anything imminent yet, but as the USGS says, if something were to escalate, then it could quickly lead to an eruption. We'll wait and see.
I did run the poll again just to figure out about, because we talked about it last time, the October 27th was the over-under line that we just threw out there type of thing. And when Lou ran the same poll on Two Pineapples and it showed the under was winning, now we have a clean 50-50 split on the 27th, so being the over-under line. So we'll see if it happens on the 27th. We'll call it a push.
We'll see if we have an orange sky for Halloween or not.
Right.
Mahalo, everybody. Once again, thanks, Dane, for leading this discussion in the chat.
Yeah, thank you.
Collecting those questions. And until next week, from the Hawaiian Volcano Education and Resilience Institute, I am Philip Ong, Dane DuPont, Carrie and Dano Kaufman, ASL interpreters, and mahalo, everybody. Until next week.